Okay, guys, let's do 9.2 really quick. You should have time to do your homework today in class, but let's go ahead and get through this. 9.2 is about tests about a population proportion. It's honestly not a whole lot different than what we've been doing in class already. So we're just going to put all the pieces together, and you guys should be successful with it. So just like when we did confidence intervals and things of that nature, we have a very specific thing that I need you guys to follow. You're going to see the template show up again, and I do that because if you follow the template, you will get all of the points that are on the rubric as long as you guys just fill in everything that needs to be there. So the first thing that you're going to see is that you do need to name the test. The second thing you need to do is you do need to have a null and alternative hypothesis. With that, you need to define your parameter. When you define your parameter, that's like writing mu and then telling me what it is. The true, mean, fill in the context. P, since we're talking about proportions, is the true proportion of fill in the context, okay? You're also going to have conditions, which we've been checking forever. You have random, normal, and independent. The only thing that changes is normal, depending on if we're talking about proportions or means, okay? Then you're going to have your math box. We'll talk about that, but more or less you're going to have a picture. You're going to have a general formula with the numbers filled in. You're going to find a test statistic, and then you'll also find a p-value. Um, you're going to have a decision or a conclusion, and since we are doing tests, you're going to do a significance test. You will be making a decision, aka write a short novel. I will help you with that. We've done a couple already. So let's go back to the Mr. Wilcox example where he shoots, his claim is that he's an 80% free throw shooter. So his AP Stats class believes that he's not really that good at shooting free throws. To prove his Mr. Wilcox went to the gym and he takes 50 free throws. And we're going to go ahead and assume that the 50 shots that he took are a simple random sample of the thousands of free throws that he has taken over the years, and he makes 33 out of those 50. Does the data provide good evidence against Mr. Wilcox's claim? Perform the appropriate significance test and use alpha at 0.01. So if I didn't say, let's do a significance test, guys, the key phrase in this is this last sentence right here. Does the data provide good evidence? That data providing good evidence is the key phrase. It's going to tell you that it's a significance test, okay? So we've done a bunch of these. Let's see. Could you guess what type of a test this is? I see one proportion. He took 33 of 50 shots, so I know it's a one proportion something. Um, when we're talking proportions, we only have one test statistic that we talk about, and that's going to be the Z. Okay, and they'd like me to do a test. So is anybody surprised when we go ahead and call this the one proportion Z test? Nope, not me either. Okay, so let's go down to the hypothesis test. See if you can fill in the hypothesis test. Can you give me a parameter? Hopefully you know we're talking about proportions and what that parameter is. Can you define it? The true proportion of what? Can you give me a ho and a ha? Ready, go. So hopefully you came up with the true proportion of free throws made by Mr. Wilcox. We're talking about the true proportion, like what is he really? Hopefully you also came up with that your ho is his claim. The claim is that he is an 80% free throw shooter. His class believes that his claim is wrong and that he is less than an 80% free throw shooter. They gave us alpha. They told us to use an alpha of 0.01, which you guys can connect. We talked yesterday about power. We talked about type 1, type 2 errors. So this guy right here is the probability that a type 1 error is going to occur. And then we have the p-hat, or the proportion of shots that we observed him making. So 33 of 50 gave us 66. That was our sample, okay? We're going to check the conditions. You have random, normal, and independent. See if you can do that. Hopefully random is the easiest one. You look up here and it says that he took 50 shots as being a simple random sample of the thousands. So hopefully random is just in quotation marks. When we get to normal, normal changes if we're talking about proportions or if we're talking about means. So when we check normal for proportions, we're going to check NP greater than or equal to 10. And we're also going to check N times 1 minus P greater than or equal to 10. This is also known as your successes and your failures. So if we go look at his successes, if he takes a sample of 50 and he really is an 80% free throw shooter, we're going to expect him to make 40. Common mistake here is that you guys will put 66% here because that's what p-hat is. We're talking about the population and we're assuming that that claim is true, so that's why we're using the 0.8 and not the 0.66 from up here. So if we do that, we get 40 is greater than or equal to 10. If we go and find his failures, 10, it's close, but it is greater than or equal to 10. So if we did this a lot, we would expect all of those little p-hats to become approximately normal when we pile them on top of each other. So we're going to assume that the sampling distribution of p-hat is approximately normal. Now, in order to do that, we have to also check to make sure that we are independent, because those two equations only work if we're independent. So we come down here to check independence, and technically those shots are with replacement. But if we want to be super sure, we're going to check that our sample is less than or equal to a tenth of the population. Is 50 less than or equal to a tenth of thousands of free throws? Yes. It just has to be at least 500, and thousands of free throws would say that that will be independent. Okay? So let's go ahead and do the math box. Remember, we want to know, just by chance alone, if Mr. Wilcox really is an 80% free throw shooter, how likely is it that he goes to the gym and he gets that 66%? So when we set up our math box, we have this. This is what we're looking for right here, okay? So when we look at this, we're assuming that 80% is what it really is. We would look at the probability that he shoots 6% or less. That appears that value or extreme. So what is the probability that we land right there in our curve? That sounds like a normal CDF. When we find our standard deviation, remember standard deviation is our P times 1 minus P over N. It's not P hat in this scenario. If we know the truth, we use the truth. And we are assuming the point is the truth. That's why we're going to use 0.8. Okay? So we stick all that in our calculator normal CDF, and we get a p-value of 0.007, which probably looks familiar because we've done it a full time now since I've introduced this problem. If you're using your test statistic and you go and Z, here is what you observed minus the actual value of the standard deviation of the statistic. Z of negative 2.47. So we go to the display, and on the left side you go down to a negative 0.4. At the top hand side you go 0.07 and you come together. You will be at 0.011. So we need to make some sort of a decision. We're either going to reject our null hypothesis or going to double check. So remember, the original problem they told us to choose 0.01 or we're going to compare this 0.07 to 0.01. Okay, this is smaller. So if P is low, we're going to reject the hoe. Okay, so we're going to reject our null. So here's what it's going to look like. Assume the null is true. There's a 0.007 probability of obtaining a p-hat value 0.66 or lower. Pure by strong evidence against hoe and statistically significant at 0.01 law. Therefore, we're going to check the null and conclude that the true portion of 53 made mistakes is 8%. Okay. That is all we're doing tonight. You guys have one more on your note, and I want you to do this on your own, and we will check it when I get back. You also have my uploading so that you guys check. But I did do it without looking at it and see how far you guys can get. Okay, you should be able to start homework today. And this homework is now on today. So page 5, 27, 3 on the paper. It's also going to do on Friday when we turn our homework in. Thanks, guys.